Welcome to my 100th YouTube video. I thought we'd do something special for this one and combine my old video style with my new one. My first video was expanding double brackets, so I thought for my 100th video we'd expand 100 brackets. This is a binomial expansion question, since we're expanding brackets of the form a plus b to the power of n, where a and b are terms and n is a positive integer. The binomial expansion is a rule that allows you to expand brackets in that form, and I'll explain how to use this rule soon. Before jumping to the 100 bracket expansion, let's see how this expansion works in general. Say we had x plus y to the power of 4, which is equal to x plus y multiplied by itself 4 times. And now say we wanted to find the y squared term of this expansion. When we expand our brackets, we can get y squared if we multiply the first y with the second y, or the first y with the third, or the first y with the fourth. We could also multiply the second y with the third y, or the second y with the fourth y. Notice we're not multiplying the second y with the first y again, because we've already done that once already, so we don't double multiply. And another way we can get y squared is if we multiply the third y with the fourth y. We can see here that there are 6 ways of choosing multiples of y using 2 brackets to get y squared. So this is just 4 choose 2, which can be written like this mathematically, or this. Since we have 4 brackets to pick from and we need to choose 2 terms from that. So this means that the y squared term is 4 choose 2 times by y squared, and the other terms are going to be x times x, so we have x squared. Since we have 4 brackets, we're choosing 2 y's, that means we've got 2 x's left to pick. So we can see how this relates to the formula where we had nr, a to the power of n minus r, times by b to the power of r. R is the number of b terms we want, and since we have n brackets to pick from, we have n minus r, a terms left to pick. The way I remember what to do is that the powers of a decrease as the powers of b increase with each term, and we multiply by the choose function of n choose the term we're on, starting at 0. So if we had n choose 0, that's just equal to 1, and 0 is the power of the second term in the first part of the expansion, so we just don't write that out. So let's go back to our question and apply the binomial expansion to 2 minus 4x to the power of 100 to find the first 5 terms in increasing powers of x. If we look at this, we can identify our a value as 2, our b value as negative 4x, and it's super important that you remember the negative sign here. And the n that we're raising the power to is 100. So first, we're going to choose 100 lots of the a term and 0 lots of the b term. So there's only one way to pick 100 lots of 2 from 100 brackets. So it's like doing 100 choose 0, which is just 1. So we can just write 2 to the 100. Then we're going to systematically increase our powers of the b term, since that has the x value, and we need the first 5 terms in increasing powers of x. So we're going to choose 1b from 100, so we get 100 choose 1. This means we have 99 a terms, and our b term is negative 4x. And we've just got one of that. And we can see 99 plus 1 gives us 100. Then we're going to continue increasing our powers of b and the number we're choosing in our choose function. So then we get plus 100 choose 2, 2 to the 98, negative 4x squared. And we're also decreasing our powers of a as we do that. And we need to ensure that the power of a and the power of b sum to give us n, which is 100. Doing the same thing, we get 100 choose 3, 2 to the 97 times by negative 4x cubed. Notice I'm also raising the negative sign to the power 2 because that's super important as it affects the sign of that term. So then my 5th term is 100 choose 4, 2 to the 96 times by negative 4x to the power of 4. Don't forget we still have this constant term, which is why this is our 5th term, even though we're raising to the power of 4, because here we're doing n choose 0. So we start counting from 0 upwards. Now all I have to do is put these into my calculator and write down my answers. I'm writing the answers as I see them in my calculator. So 2 to the 100 gives me 1.26765606 times 10 to the power of 30. And I'm going to put each of my terms in brackets so we can see the terms separately. Then when I put this term into my bracket, I'm raising negative 4 to an odd power. So I'm going to get a negative value. So I get minus 2.535312 times 10 to the power of 32, and I'm not going to forget to put my x term afterwards. And I'm going to continue to do the same for the remainder of my terms, so we'll just fast forward this part. And since we know that this expansion can keep going on and on and on until we decrease our powers of a and increase our powers of b to 100, we can just do plus ... to show that there are more terms in this expansion. And that's it. Note that we could have also factorized out the 2 to the 100, so we would have just been expanding 2 to the 100 times 1 minus 2x to the power of 100, and we still get the same answer when we expanded that all out eventually. So that's it for my 100th video. Thank you all for the support you've shown me over these years, and I hope you're excited to see what comes next.